Okay, real quick, last thing, we're going to do pedigrees. Basically, we're going to look for patterns of inheritance in a pedigree in a family tree. It reveals a pattern of inheritance and it looks for modes of inheritance, and this is phenotype in humans because we don't breed humans, we don't experiment with humans. So with humans, we sort of have to work backwards, and we do that with pedigrees. Basically, genetics follows a constructed pedigree, and some of these are illustrated. I will bring up some of the pedigrees that we have and show you what the signs mean, because I will ask you some pedigree questions, and you're basically just going backwards to try and determine the genetics of the parents. Parents are connected by a single horizontal line, and vertical lines lead to their offspring. If parents are related, yeah, that happens. Welcome to the English monarchy. Or if they're cousins, they're connected by a dotted line. Siblings are connected by a horizontal, like sort of a ship line. I'll show you. Females are designated as circles, males as squares, unknown sex as diamonds. Generations are designated by Roman numerals. Siblings are placed from left to right in order of birth. Shading indicates expression of a phenotype. Heterozygous individuals who do not express the trait but are known carriers have a dot. Twins are indicated by diagonal lines stemming from a vertical line. Identical twins are indicated by diagonal lines. Fraternal twins by connecting lines. Deceased individuals have diagonal lines through them, and individuals for which the pedigree was constructed is the P. So here's the chart: female, male, sex unknown, affected individuals, parents, related individuals, offspring in birth order, fraternal versus identical twins, male, deceased individuals. So that's just sort of the key for how we're going to use that. Two pedigrees here are illustrated. The first one illustrates an autosomal recessive pattern of inheritance. So you've got to have both of them that are recessive. And the second illustrates an autosomal dominant parent of inheritance. Okay, the first one. Let's see what we can figure out. Okay, so we've got a dad over here who has the trait. Marries, none of his kids have it. Then you have just some other set of parents here, right? These two marry, right? They've got two kids that have the disease. What is happening? It cannot be dominant, right? Because at some point you would have seen it in this generation. So it's got to be a recessive trait. What you're going to want to do is you're going to go here and put like big A, little a. Big A, big A. And then you're going to see that basically here you've got no connection. What you've got here is a big A, little a. Again, or this person has to be little a, little a. This person has to be big A, big A. Everybody's a carrier, right? So now you've got this person who marries this person. Basically, this person has to be a carrier too. Otherwise, you wouldn't get little a here and little a here. Does that make sense? You just have to work backwards. You have to say, if nobody in this generation has it, it's got to be recessive. Okay, now let's go to the second one. We've got dad who has a trait, mom who doesn't have a trait. They've got 1, 2, 3, 4 kids. Half of them have the trait. Okay, mom doesn't have it. Dad has it. So if it's recessive, we wouldn't see this here. So this has got to be a dominant trait, right? Dad has the big A, little a. Mom is little a, little a. So half of her offspring got her little a and dad's little a. Past the big A here, past the big A here, then this kid, we see it again with the dominant, we see it again with the dominant. This is just process of elimination. We will do a couple of these in class. You're basically just going backwards and putting what you know. So you know this person has it, you know none of these have it, and you're kind of just predicting it and going backwards from there. Tay-Sachs disease. TSD is a recessive gene causing multiple effects. It's a recessive disorder. It's a destruction of the nervous system. Results from a loss of activity of the hex A, needs to break down. So essentially, we could look at that here. If we want to go back, let's look at this in that term. Okay, so we've got little a, big A, little a, or big A, big A. All of these, big A, little a. Okay, so we know it's recessive. But this little a is still up here. This, let's say mom breeds true, so we have big A, little a, all the offspring are big A, little a. Somebody here, a grandma or somebody, gave someone one of these little a's because this person clearly is big A, little a, and this person is big A, little a because they don't exhibit the trait, but they gave it to two of their offspring. Does that make sense? Okay, this was a short one. We will do some of these in class. I'm going to put a quiz online that will be low stakes. You can take it twice. I just want you to be working through some of these problems. I may put another one that I'll grade as a homework grade just so you can start getting a chance to work through them. And then I'll put a recording about how I work through them. Okay, bye guys.